video, I'll do a demonstration of exercise B1. This exercise will familiarize you with implementing scripts to create building geometry, matching surfaces, creating thermal zones, and adding output variables. We're going to start in SketchUp with the OpenStudio plugin open. In step 2, we're going to use the OpenStudio plugin toolbar to create a new OpenStudio file. This is very important. Don't proceed without doing this step. If you do, your file will be full of a bunch of extra junk that may cause confusion and problems later on. To do this, we're going to click the New File icon in the OpenStudio toolbar. And we don't need to save our current model because that's a prototype default file that we don't need. It's telling us the model is totally empty right now, and we'll need to run the script to get defaults in here that will be useful to us. Step 3 will be to run that script. So we're going to go to the Extensions menu, OpenStudio User Scripts, On-Demand Template Generators, Space Type, and Construction Set Wizard. We'll stick with the building type office. You can see the other choices we have here. We're going to use the ASHRAE 90.1 2010 template. We're going to choose Climate Zone 2A. And we're going to leave the rest of these set to true. It's going to create space types for us, create construction sets, and set building defaults using those. It will take just a moment for that script to execute. And now it tells us we have 13 space types and 1 construction set in the model. Next, we're going to create some building geometry. We'll do that by going to User Scripts, create standard building shapes, and we're going to use the T-shaped floor plan. Here we're going to accept all of the defaults, except set the number of floors to 3. If we were doing a real project, of course, we would adjust all of these to the specifications of the project. Again, it'll take just a moment for the script to execute, and we should see a building pop up with 3 floors that looks something like this. In step 5, I'd like you to select all the geometry of the building, which you can do on Mac by using Command A, PC, Control A, or drawing a selection box around all the geometry. We're now going to match the surfaces, which tells it that the surfaces that enclose this space and face this space are contiguous with the surfaces that enclose this space and therefore are not duplicates. Surface matching tool is the plane with the arrows that go both ways through it. I'll click on that. And then I'm going to choose Match an Entire Model. It warns me that I can't undo this, and it's going to create new geometry. OK. Now, to verify that that's worked, in step 6, I'm going to set the render mode to boundary condition in the toolbar. That's this blue volume up here. And I'm also going to select this wireframe box that will hide other model elements when I edit a space. So now if I double click on one of these spaces, it's going to hide the rest of the model. I can orbit around. Oops. I can orbit around and see that now these surfaces are green. Blue surfaces are facing the outdoors. Green surfaces have a boundary condition of another surface, and that indicates that it's now been properly matched up with those other surfaces. Before I ran this step, these surfaces would have all been blue, and if I hadn't done the surface matching, it would have modeled each of those surfaces as if they'd been in contact with the outdoors. I'm going to click out of that, and just to verify for my own edification that all of that worked properly, I'm going to look at the adjacent zone and see that now this surface is actually matched to the other one I just looked at, and I can see that all the appropriate surfaces are properly matched up. In step 7, I'm going to create thermal zones for all of these spaces. So once more, I'm going to select all. I'm going to go to Extensions, User Scripts, Add or alter model elements, and then add new thermal zone for spaces with no thermal zone. So it should now create thermal zone for each one of these spaces that was already in the model here. To verify that that worked properly, I can come up to this toolbar and select Render by Thermal Zone. And now I'll see that there's a different color scheme that's been applied to each of these. And if I click on one thermal zone and I select my inspector tool, I can see that this thermal zone is thermal zone 27. If I check another one, I'll see that it's thermal zone 4. Sometimes the colors assigned are very similar, and you can verify that they're each individual thermal zones by clicking them individually and checking the number. We actually want to record the number of this thermal zone. The model won't always assign the numbers identically, so you need to check specifically. In this case, it assigned it thermal zone 27, and we'll use that later on in the exercise. In step 8, once more with all of the building geometry selected, we're going to set the thermostat conditions by going to the Attributes tool, which is the icon with the hammer and wrench. Here we could change many different things, but in this case we're only going to set the thermal zone conditions to ideal loads. We'll choose yes for that, and the parent thermal zone's thermostat to open office. This is a good time to save your model. You generally want to save frequently, and you do not want to save using the SketchUp save command under File or just Command S or Control S. Doing that will link your OpenStudio model to a SketchUp model and can sometimes lead to problems. You want to save using either OpenStudio File Save or the tools in the toolbar here, which are the same. So I'm going to do Save As in this case, and I'm going to save it to my desktop with a name that makes sense to me. I'd strongly recommend that you save frequently and save multiple versions of your model in case issues develop where you need to go back to previous versions. Once more, in step 10, we're going to select all the building surfaces created. We're going to go back to the user script menu and set the window to wall ratio. Extensions, user scripts, add or alter model elements. Set window to wall ratio. We're going to use a ratio of 30%, and we're going to offset the windows a meter above the floor. So you can see now that windows have been added to the model. If I go back to rendering by surface type, first option here in the rendering toolbar, now I can see that I've got strip windows that have been applied at a 30% window to wall ratio. For step 11, we're going to add overhangs to the model. Once more, we're going to select all. Go back to extensions, user scripts, add or alter model elements, and add overhangs by projection factor. We'll use a projection factor of 0.4, which means the overhang will be 40% as deep in the horizontal direction as the window is tall, and we'll use 0.2 for the top offset, which means that the overhang will be 2/10 of the total height of the window above the top of the window. In this case, remove existing space shading is not relevant because we have none. If we did, we could choose either yes or no if we wanted to keep or override any existing shading devices. We'll say OK, and now we can see that the overhangs have been added all the way around the building. For step 12, we're going to save and close the OpenStudio model. So I'll save once again. I find the easiest way to close the model to be choosing the new OpenStudio file option. I can choose either yes or no saving here because I've already saved it. I'll just choose yes once more, and that's just telling me the new model is empty. I'll now switch over to the OpenStudio application, where I have, by default, the empty template file open. I want to instead open the file that I've just created, so I'm going to use the open command, select my OpenStudio model, which I had saved, in this case, on my desktop. I don't need to save my existing model. My first step in OpenStudio is going to be to set the weather file in step 14. I'm going to choose the same weather file that I used for exercise A, the Austin Camp Mabry weather file. I'll then go in step 15 to the Output Variables tab and scroll way far down to choose Zone Outdoor Air Dry Bulb Temperature. Once I turn that on, by default, it will come up as hourly, and I'm going to leave it at hourly reporting. So this will be the variable that we've asked it to report time series data on for the simulation. In step 16, I'm going to load the same measure that we used in exercise A on the Measures tab with the scroll. It will generally take a moment for that to pull up. Once I do, if you're working on a computer where that was loaded previously, the measure should already be on there. So we should be able to go to the Building Component Library Measures Library, which is over here on our right-hand pane, under Reporting, QA/QC, scroll down to find OpenStudio results, and I will just drag that over into Reporting Measures. I see it appear here, and I know it's in there. Step 17, I'm going to save my model once more. Step 18, I'm going to run the simulation. So I go to the Run Simulation tab, click Run. I'll allow incoming network connections. And on my computer, it takes about a minute for this file to run. A little bit of a wait, but for a 3-story office building with 20 some odd zones, not too bad. Once the window shows completed at the bottom, I know that the simulation has run successfully, but there may have been errors created that we should know about. So the first thing I'm going to do is click Show Simulation, and then open up the file named e+out.err. If you don't already have an application named to open that kind of file, choose a text editor, and it'll be able to read this. So I have a number of warnings here. None of them look severe at this point, or look like they're of major concern. If it's labeled warning, that means it's something the program thinks you should be aware of, but it didn't interfere with running the simulation. If anything is marked severe, it's something that definitely needs to be fixed, and most of the time a severe error will lead to a fatal error where the program closes and doesn't complete the simulation. So reading these reading the notation on these errors is usually pretty straightforward. You can see the objects or the processes that cause the simulation to fail or creating an issue, and then you can research those and troubleshoot what the problem is. Looks like there weren't any significant problems with this, so I'll close that. In step 19, I'm going to check out my results. So I'm going to go to the Results tab, and I see the OpenStudio report shown. If I hadn't chosen that measure that created this report, I would see just the straight Energy Plus results, which look like this. Has most of the same information, but it's presented in a more opaque and less graphically pleasing way. So I strongly recommend using the OpenStudio results measure to create this report. We're going to make note of the total building area that we'll use later on. As far as the EUI of the building, right now this is pretty much meaningless because we used an ideal loads air system and it modeled all of the space conditioning as if it had a COP of 1 or 100% efficiency in its space conditioning. So it's not really telling us much in terms of the actual performance of the building. It's still useful, this type of model, for looking at impact of envelope changes on heating and cooling loads and studying the way the building performs in the larger sense. But as I said, it doesn't help us really understand how much actual energy the building is using at this point. Next, we're going to look at the time series data in DView. We can either do that by clicking on this button to open up DView, or we can go to DView directly, which I'll demonstrate here. When we open up DView, I'm going to open my file that I just created. So I'll navigate to the location where I saved my OSM file, and there'll be a new folder or directory that's been created there that has the same name as the OSM file. I'll open that. I'll open run. And then I'm going to look for the file that ends in .sql. So this is a SQL database file. I'll open that, and we can choose whether or not we want to display the energy, the data in IP units or not. In this case, I'll select yes. And I'm now going to navigate over here in the right-hand pane down to the zone under zone outdoor air dry bulb temperature. This was the variable that I turned on under the output variables tab, and locate thermal zone 27, which was the one that we noted at the beginning of the exercise. Turn it on using the left radio button. And I'm going to scroll over to find the date of April 24th. So here we are on April 24th, and I'm going to record the highest air temperature on that day. You'll enter this value into the class table. And then I'd like you can zoom out using the zoom out button. And I'd like you to explore this data a little bit. Try to understand how the building is performing, see what trends you see, and see what sort of patterns in the fluctuation of air temperature that you see. We'll spend more time analyzing data like this later on in the semester. Last step will be to submit the OSM model, only the model, that is, not the accompanying folder, into your student work folder on Box, and that completes exercise B1.